Good morning, student. We learned last class for measurement. Already seen about the introduction for measurement. What is measurement? What is the importance of measurement? And what is the system of units? In ancient days, we learn different countries having a different type of system. For CGS system, then FES system, then MKS system. CGS system means centimeter, gram, second, and FES system means foot, pound, second. MKS system means that is a metric system, meter, kilogram, second, having some different type of system. So different countries having some different type of system. So it is very difficult to learn the scientific fact exchange from one country to another country. So overcome for these difficulties. So in our World Scientist Conference at 1960 to form a SI system, that is System of International, already seen about the last class. Now the System of International, they frame a 7 fundamental quantities and some derived quantities from these fundamental quantities. Then what is the importance of fundamental and derived quantities? Now we see about one by one. For the SI system of units, it is based on the certain set of fundamental units from which derived units. So all the derived units derived from the fundamental units. You know already fundamental quantities, derived quantities. Fundamental quantities, it means that the quantity cannot be expressed any other physical quantity. For derived quantity is a quantity derived from any other physical quantity is called a derived quantity. So the fundamental units, the units measured the fundamental quantities are called fundamental units. The units measured from the derived quantities are called derived units. You know the fundamental quantities, length, mass, time, and derived quantities more. Area, volume, density, acceleration, velocity, all are derived quantities. Now the SI system frame the 7 fundamental quantities. First one, length, mass, time, temperature, electric current, luminous intensity, amount of substance, all are called fundamental quantities. For length, the measured by meter, the symbol M. Mass, kilogram, kg. Temperature, time, second, yes, temperature, Kelvin, K, electric current, ampere, luminous intensity, candela, amount of substance, mole. All these 7 quantities are called fundamental quantities. And also 2 supplementary quantities you learn in a higher class, first radian and steradian, having 2 supplementary quantities. Now we seen about the derived quantities. For example, area, volume, density, velocity, momentum, acceleration, force, pressure, energy, surface tension, all the quantities are called derived quantities. How will you form a derived units? Now you see area, formula, what about the formula for area? Length into breadth. Length is measured by meter, breadth is also meter, so meter square. So the unit of area is meter square or square meter. Then volume, the formula for volume, area into height. That means length into breadth into height. So meter square into meter, area meter square, height is expressed by meter, so meter cube. So volume, area are derived quantities and meter square, meter cube is a derived units. Then another one, density. The expression for density, mass by volume. So the unit of mass is kilogram, unit of volume meter cube. So kilogram per meter cube is a unit of density, or kilogram meter minus 3. So meter cube taken to be reciprocal, we get kilogram meter minus 3. Then velocity. The formula of velocity, displacement by time. The displacement is expressed by meter, time, second. So can write meter second minus 1. So the unit of velocity, meter per second or meter second minus 1. Then momentum. The formula of momentum, mass into velocity. The unit of mass, kilogram, velocity meter second minus 1. So we get kilogram meter second minus 1 is the unit of momentum. Then acceleration. That is rate of change of velocity or velocity by time. For velocity, unit of velocity meter second minus 1 by time unit second. So taken to be reciprocal. So meter second minus 2 or meter per second square is also unit of acceleration. Then force is equal to mass into acceleration. The unit of mass, kilogram, for acceleration meter second minus 2. So we get kilogram meter second minus 2, or another one, familiar unit of force is Newton. Then pressure. The formula of pressure, force per area. That is unit of force is Newton, area unit meter square. So Newton per meter square or Newton meter minus 2. So another one unit for the pressure is Pascal. Now energy or work, both are same. So the formula for work done, force into distance. The unit of force Newton, distance meter, Newton meter, or another one familiar unit Joule. So the energy or work done having the same unit Newton meter or Joule. Now the surface tension, that means the level of water. How will you form the top of the water or top of the any liquid? Different liquid having the not a top the same top. That is a surface tension. So you will learn higher class. Surface tension is formula force per length. The unit of force Newton, for length meter. So the Newton meter minus 1. So all these quantities are called derived quantities. All these unit is called a derived units. So all the derived units is coming from the fundamental units. All the derived units based on the only for the fundamental units. So without fundamental units cannot be derived in the derived units. So some of them, the fundamental quantities and derived quantities is more derived quantities and derived units there. So you learn every lesson for higher class. Now fundamental units. What is the basic fundamental units? Length, mass, time. That is the fundamental quantities. On the fundamental units, for length meter, mass kilogram, time second, temperature Kelvin, amount of substance mole, luminous intensity candela. All are fundamental quantities. On their unit is fundamental units. Now you seen first one, length. So what is length? The length should be expressed something between the 2 points. See, here is one of the point, the one point. See, another one point. So So the extent of this point to this point, that is called a length. The extent of something between 2 points or the interval between 2 points, that is called a length. So the SI unit of length is meter, is expressed by m. So for length you measured very small distance up to measure the very large distance. So what is the minimum value and maximum value to measure the large distance? Now as you can see, first you seen about measuring the very large distance. For example, you want to measure the breadth of the room or the board, the length of the board using a tape. You directly measure the length. So 1 meter, 2 meter. So up to measure the one place to another place. How will you measure? So from Namakkal to Salem, how will you measure? So the distance is measured by kilometer. So after that, hereafter, is want to measure from earth to sun, earth to moon, how will you measure? So you use some different method of measuring the distance. First one, the astronomical units. That means the mean distance of the center of the sun from the center of the earth. That is called a astronomical unit. Simply you expressed AU. That means astronomical unit. The mean distance, see, is a earth, is a sun. The center of that is 1 AU. The mean distance of the center of the sun from the center of the earth, from the center of the sun up to center of the earth is called a 1 astronomical unit. The center of the earth to the center of the sun, the distance is 1.496 into 10 power 11 meter. That is a 1 astronomical value. 1 astronomical unit is equal to 1.496 into 10 power 11 meter. Then after that you want to measure the very large distance having the light year. Light year means the distance traveled by the light in 1 year. ஒரு வருஷத்துக்கு லைட் ட்ராவல் பண்ணிக்கிட்டே இருந்தால் எவ்வளோ தூரம் போகுமோ அதை தான் நம்ம லைட் இயர் அப்படின்னு சொல்கிறோம். ஸோ லைட்டோட ஸ்பீடு அப்படின்னு சொல்லி பார்த்தோம் அப்படின்னா 3 lakhs kilometer per second. Per second 3 lakhs kilometer can travel. That is 3 into 10 power 8 meter per second. The light travel from sun to earth 8 minutes 20 seconds. To reach the sunlight from the sun reach the earth. So 1 light year, that means the distance traveled by the light in 1 year. So the 1 light year is a measurement of galaxy, between the galaxy, from one galaxy to another galaxy, the distance of Milky Way. These distance are measured by the light year. 1 light year is equal to 9.46 into 10 power 15 meter. Now that is a very large distance. So after that, to measure the very large distance, because outside the solar system, that is parsec, the distance measured astronomical object outside the solar system. So after outside the solar system you want to measure the different astronomical object, you measure using the parsec. The 1 parsec is equal to 3.26 light year. 1 parsec, that means 3.26 light year. So the astronomical unit, only the distance center of the earth to center of the sun. Light year, the distance traveled by the light in 1 year. So these are measured only the inside the galaxy or Milky Way. So outside the galaxy, outside the Milky Way, the entire universe, you want to measure the unit of parsec. These are called to measure the large distance. So now we want to conclusion this topic. So another class you learn about the how to measure the very small distance, up to which you can able to measure micro, nano, at which part we can learn next class. Thank you, student.